Alright, I'm going to go ahead and teach lesson number 28. It's about angles. But before we start, let's review a couple concepts. Line. Line goes forever in opposite directions. How do we show that a line goes forever? In order to do that, we put an arrow at the end of the line, meaning that this line will go forever that way and forever that way. Alright, so in math, if we want just a portion of a line, it's called a line segment. And the way that the mathematicians notate that is they put a dot at the end of their line segment. Okay? Then one more point, there is something called a ray. A ray has an endpoint represented by a dot and a line with an arrow, meaning that the line goes forever that way, but it does have an endpoint on one end. Of course, you can have an endpoint on this end, and the line could go this way. Okay, you need to know these terms. A ray are those two; they go together. You have a line segment and a line. Okay, so in math, you have these things called planes. A plane is basically a flat surface. If you can visualize that, it could be a table. A table is a plane. This board is a plane. So if two lines are on the same plane, and in order to draw, actually I'm going to make a mistake. Let's see if you guys can catch it. There's a line. There's a line. These are mathematical lines. What mistake did I make? Hopefully you guessed, and you're yelling at your computer right now, Mr. Mazzone, if it's a line, mathematical line, these lines need arrows to show that they go forever in opposite directions. Okay, two lines are on a plane and they do not intersect. They are known as parallel lines. Make sense? Parallel lines do not intersect. What does it mean to intersect? It just means they cross. Okay, so these lines never cross. How do I know? They're parallel. And they're parallel because they never cross. Okay, so if lines are not parallel, at some point they're going to cross or intersect. I magically wrote that up there. Intersect, that just means the lines cross. Where do these two lines intersect? Right there. You'll hear this word intersection. That's where two streets cross. Usually there's a stoplight or stop sign or something at an intersection because there's cars that we don't want cars to collide. So most of the time, if two lines cross, they are known as oblique lines. Okay, but there is a special type of intersection that I want to talk about. And it is an intersection where you have two lines. Wait, what did I forget? You guys are already on me. I know you're correcting me right now through the computer. Mr. Mazzone, don't forget your arrows. If they're lines, they need to have arrows. Otherwise, they're line segments and they need to have an endpoint represented by a dot. Alright, these are special type of lines that cross. These lines are known as perpendicular lines. Perpendicular lines cross and they have a 90-degree angle. That means they're exactly straight up and down. Not necessarily, it depends on what your definition of up and down are. But they have, when they cross, they create a 90-degree angle. That means that you could put a little box right there. And you could fit in a square right up in this corner, and it would fit perfectly. Okay, so these are perpendicular lines. Okay, so pause your computer, your YouTube video right now real quick, and study this. You need to know all of these terms. Pause. Okay, let's talk about some different shapes that are made with rays. We have two rays right here. They both have the same endpoint, because that's what a ray is. They have an endpoint, and then the line goes forever in that opposite direction. Okay, so we have two rays, one ray going that way, one ray going that way. and they go in the opposite direction, they form a vertex. A vertex is the endpoint where the two rays intersect, so to speak. So this vertex right here, if I can get out of the way, this vertex is going to have a name. We're going to name it. The little point that's created when two rays have a common endpoint is called a vertex, but we're going to name this vertex. We're going to name him B. I don't know how I decided that it was a he, but this vertex right now is named B. Okay, so what we would name this vertex right here is vertex B. This is a notation you would use to refer to this shape right here, this endpoint. So let's talk about angles. Angles are created when you have two rays that have a common endpoint. It's the measure of how much room, so to speak, not exactly room, but it's the measure of how much space is in between those two rays. So I'm going to call this dot right here A, and this point right here C. The correct verbiage of that would be point, not dot. Okay, so this point would be C, this point would be A. If I wanted to name this angle right here that went from C to B to A, I would name it, that means angle in math, I would name it A, B, C. Since B is a vertex, it should always be in between the other two labels, other 2 points. I could also name this angle C, B, A. Okay? Notice, B is in the middle of the two other letters. Okay? You cannot name it angle B, A, C. This would not be a name of this angle over here, because B is not in between the two letters. Alright, one last way that we name angles. So if you have a line, and on that line there's a point, and from that point a ray shoots out. Okay? It's not a very good angle or arrow, is it? Alright, anyway, so here's a line and an angle shoots out. We'll call this angle 1. That angle is made up of this line, this ray right here, and this ray right here shooting up, and angle number 2. So we have angle 1 would be all of this area, and angle 2 would be all of this area. And the way we would name that is angle 1 and angle 2. Okay, I'm going to talk a little bit more about perpendicular lines. So if there are two lines that intersect, they form a 90-degree angle. 90 degrees is an important angle. We use it in a lot of different situations. But that 90-degree angle has a special symbol to note that this is 90 degrees. And if you guys have ever seen, it's like a little box, right? In between two lines, this right here shows that this is 90 degrees. You could do one over here as well. That's 90 degrees as well. Okay? So those little boxes mean that the angle that is created by those two lines are exactly 90 degrees. Okay, example number 4 here. If you have oblique lines that intersect here, they're not perpendicular, meaning they don't have 90-degree angles. You can see that this angle is, there's a lot of space in between this line and this line over here. Okay, if you have a lot of space that's more than 90 degrees, that would be known as an obtuse angle. Okay, remember that little symbol means angle. Is this an obtuse angle? If you looked at this area right here, all this area right here, you would see that it's smaller than 90 degrees. If your wall, if this is the ground and this is a wall in your house, you would be, the wall would be hitting you in the head. It wouldn't be going straight up. Okay? that's a good way to think about perpendicular, 90 degrees. 90 degrees, we use 90-degree angles to build walls in our house. And if a wall is not going straight up, that means it's not 90 degrees. You want your walls to be 90 degrees because you want your walls to go straight up. Imagine the wall is like tipping over and about to fall. That would be an acute angle. And that's what this, say this was your ground level right there. You're walking right there and your wall is falling over. Okay? And if it's going to smash you to the ground, then that is called an acute angle. The way that I always remembered what an acute angle was, I had a teacher who was kind of funny. And he said, acute angles are little angles. Oh, they're so cute, he would say. And so that kind of cracked me up and helped me remember what an acute angle was. Acute or small, obtuse or large angle. Okay, review real quick. This is an angle. The way we name this angle is ABC. ABC. B has to be in the middle. Another way to name angles are, you could say that this is angle number 1, angle 1, and angle 2. Angles that are 90 degrees have this little symbol right here in the corner that shows that they are 90 degrees. If this is ground level and this is a wall right here, it would be going straight up. Okay, so that's one way to think about 90-degree angles, are they're going straight up from the ground. Then we have obtuse angles. Those are large angles. And acute angles. Those are small angles. They're acute. Alright, here's example number 1. If you want to pause the video really quick and do it yourself and see if you get the same answers that I'm going to give you, this would be a good time to do it. Name the acute and obtuse angles in this figure. So, here's a line and a ray shooting up. Go ahead and name the obtuse and the acute angles. Alright, now that you're done with that, let's go ahead and do this. Obtuse would be this angle right here. The big angle. Obtuse. The little tiny angle, that's the acute angle. Aw, it's a cute one. Okay, so we have right here angle A, B, C. That's our obtuse angle. Okay? ABC is our obtuse angle. So this little acute angle would be angle, I'm going to make a mistake. Let's see if you guys can catch it. B, C, D. Why is this notation incorrect? You are correct if you're saying that the vertex right here, if you were to cover this part, you would see that this is the vertex, the B is the vertex for these two rays, is B. That means that B should be in between the letters. So this would be angle C. B is a vertex, D. Okay, and that is our acute angle. Alright, here's a quadrilateral. 4 sides. It's definitely not a square. Definitely not a rectangle. But this is a quadrilateral, which means it has 4 sides. We need to find the acute angle. The acute angle is the small angle. Okay? Forgot to put those right there. Alright, so would this be an acute angle? Absolutely not. Would this be an acute angle? Now that's way too big. We want a small little acute angle. In this case, this right here, C, would be the acute angle. Okay, so how we would write that is B, C, D. Angle B, C, D. Notice, C is in between the letters B and D. And that's because this is the vertex of the angle. The vertex is the point. Okay, now let's do the obtuse angle. The obtuse angle would be not this one right here and not this one right here, because those are perpendicular. Remember, perpendicular would An example of a perpendicular angle is an angle that is created from your floor and your wall. You definitely need a perpendicular angle in that situation because you want your wall going straight up. You don't want it falling over into the house or falling over outside of the house. So this would be our obtuse angle. So here's your little angle sign. Okay, and the way you would note this would be angle A. B is the vertex, that's the point, and then C. Alright? Last one is our right or perpendicular angle. There's actually two of them. Remember, perpendicular and right angles, which is the same thing, right angles are perpendicular, and whenever you have that situation, you're going to see a little box in the corner. That shows that those are perpendicular or right angles. Alright, so let's go ahead. And this would be angle BAD. Angle BAD. Bad to the bone. And then if you wanted to write this angle right here where D is the vertex, you're going to do angle ADC. You could also do angle CDA as long as the letter D is somehow in between the letter A and the letter C. Okay? So that's pretty much angles. We might do one more.